Alright, we're going to take this video to look at the component method of solving vector addition problems. This will be the second of the two methods that we have discussed here in class, and in order to look at this video I've decided to use the software that I showed in class. If you want to see this software for yourself, of course there is a link on the website that you can click on. If you just go to chapter 3, it'll be right there. So what we're going to do is we're going to look at what vectors I've already started right here. So you can see kind of the graphical addition vector that I did right here. As a matter of fact, here's what I'm actually going to change this slightly. I'm going to add another vector on top of this so that we can see, because we typically do two. Let's put three vectors in this problem, still ending at about the same spot. Alright, so the nice thing about this software is it shows us exactly right up here what our answers should be on each vector. If we just click on that particular vector, it'll tell us what it needs to be. So let's write down the vectors that it gives us. Now, when you get these originally, you're going to be given magnitude, or the absolute value of r, and angle. You're not going to be given these. These are what you're going to have to be able to figure out. So let's start with just these two numbers here and write down what we have. The first vector is 34.1, whatever units you want. I'm going to choose newtons for this, at 31.8 degrees. So I've transferred the three vectors that we're going to use right over here. We have 34.1 newtons at 31.8 degrees, 24.2 newtons at 172.9 degrees, and 26.4 newtons at a negative 119.5 degrees. It's a good idea for just quick review to point out which quadrant this should belong in. 31, that's a positive angle, so we're going to measure that counterclockwise, and since it's less than 90, that means that's going to be in the first quadrant. 172.9, it's above 90 and positive, so that's going to be in the second quadrant because it doesn't quite get to 180. And finally, negative 119.5, the negative tells me, of course, that it's going the clockwise direction, so somewhere down here, and it's above negative 90, so it's going to be somewhere in the third quadrant there. Alright, so what we're going to do for each one of these vectors, try to figure out how much goes in the x and how much goes in the y. So we're going to break each of these vectors down. I'll call this 1, call that 2, and call that 3. So here we go. I need to find x1 and y1. In order to do that, I'm going to use trig. Now, if you need to review on trig, there's going to be a video for that. But for right now, I'm going to assume that you've watched that video so that you know that the x, if measured from the x-axis, will always be cosine. And I need to specify again, that's only if it's measured from the x-axis. So what I'm going to do here to find the x is just take the magnitude of 34.1 newtons, 0.1 newtons, cosine of 31.8 degrees. Y is going to be that 34.1 again, newtons sine of 31.8 degrees. And using the power of video, I'll now do the other ones extremely quickly. Behold, that magic happened right before your eyes. So we just did the exact same thing for the second vector and the third, so now we'll have a total of 3 different x's and 3 different y's. What this means is exactly how far each vector will go along the x and go along the y. Now, again, using the power of video, I'll solve all these. There we go. So just solve all these, punch these into the calculator. You'll notice that I was very careful with keeping my units here, as well as I put the x hat with the x value and the y hat with the y value. Because with all this giant mess on your page, it's good to just be able to look over here at the numbers and know with the x hats that they all belong to one another. So now the final thing that you're going to do is you're going to take these components and add them together. What this component means, again, is exactly how far it's gone along the x. So we're just doing this one number line at a time. 29 plus the negative 24, of course, is a positive 5, plus the negative 13 is going to give me a negative 8. So if I take x total, it's just going to be x1 plus x2 plus x3 plus however many x's there are, and that ends up a negative 8 newtons x hat. And y total is done the same way except with the y's, and the answer in this case I believe ends up being negative 2 if I'm not mistaken, but let's check this. 18 plus 3 is 21, minus 23 is yes, negative 2 newtons y hat. Finally, in order to get the answer in terms of magnitude and direction, this is in fact a correct vector right here. However, in order to get it in terms of magnitude and direction, I'm going to use my triangle. I'm just going to, since these are the two values, I can see that from the two negatives that this should end in the third quadrant. So I'll start with the magnitude here, just using Pythagorean theorem. The magnitude is equal to the square root of x total squared plus y total squared. And the answer is just 8.2 newtons. Not very much above 8, which makes sense because that's the longest line, and that's going to make the most difference there. Alright, and the angle, of course, will happen with the inverse tangent. That will be the inverse tangent of y total over x total. And the answer that the calculator gives us is, the answer that my calculator gives me is 14 degrees. Now I pointed out just a moment ago that these are both negative values, and so it should be in the third quadrant. Your calculator has a difficult time with this because the negative and the tangent give it a positive ratio, and so it tells you that it's in the first quadrant, even though you know right from right there that it's in the third. The simple fix to that is just to add 180 degrees, and so that you get your final answer is 196 degrees. And all the component problems can be solved this way.